Alrighty, we are online. We have about a minute to go for day 10. Tonight, hopefully it's a shorter problem because I have a pretty hard cutoff of around 11. Got an early morning, so fingers crossed we'll be able to solve this in a reasonable time, unlike last night, in which I got stuck up on little details forever. Seems I wasn't the only one, but other people did use a lot of persistent data structures, or transient data structures rather, and a lot of them actually use double-ended queues, which I moved to in Java after the stream ended, and that was so much faster. So, lesson learned, learn the right tools, and use the right tools for the job. So, I'll modify the Clojure thing to use a deck later, I think. As it stands, we are on problem 10. Trying to navigate, we see points of light floating in the distance. We record their position in the sky and their velocity, and the relative change of position per second. Okay, so we got position and velocity recorded, basically. Given enough time, these positions and velocities will move the points into a cohesive message, quote-unquote. Rather than wait, we're going to fast-forward the process and calculate what the points will eventually spell. Oh crap, these have to create like a series of letters. Oh no, this is going to take forever. I might not be able to do this tonight. We'll find out. Each line represents 1 point. There's XY pairs, okay. So every second they move according to their velocity, and they make letters properly. At this point, I'm not going to try and interpret the letters automatically. I'm just going to print it out and interpret it by hand because screw trying everything else. Okay, so I hope anyway. This could get messy. Okay, here's our inputs. On the bright side, I think this is a suitable one for Clojure. Not that complicated, really. As far as things go, there's like built-in stuff for all this. So, let's read that in. I think it's... RE parse. I don't like my RE parse right now. Shoot. RE matches. Excuse me. Interestingly, it's all columnar, so I could solve this in COBOL if I wanted to. It's a joke. Interestingly enough, what we're going to want to do is actually we're going to want to translate this a bit because these are all over the place in massive numbers, and we don't really need all those massive numbers, I think. Or we're going to wait until they get to a reasonable proximity to each other, so that when the bounding box is small enough. I think that's what we're actually looking for here. Okay, we'll try that out. position equals okay, we're going to copy this a couple times. All this stuff again. It's a bit crude, but it's sufficient for our purposes, and that's what counts in these kinds of scenarios. Okay, it's also going to be kind of long, but you know what? Let's just... Oh, what? Oh, I said mark. Come on. Delete. PX, PY, ZX, VX, VY is our okay. Tick points. Keys, os vel. As point. There we go. So let's try ticking a point that is at position 1, 2. Vel 3, 4. So I should get 4, 6. 4, 6, 3, 4. And we're good. Let's use map V here, just to be consistent. There we go. Now we have a vector of position. Okay. I think we're good. You honestly could use maps. I just, for some reason, I reach for vectors first in a lot of cases. Maybe that's not going to be as efficient in most. But regardless, I think we're safe. Let's see. Okay. Let's go ahead, delete this, and move on. Our parsed input for our map. Let's move this up. There's no way to move definitions up and down that I know of yet. I'll have to find that later. Is it control down? Shift down? Nope. Okay. Whatever. Our parsed input is going to be mapping our parseLine function on, I think it's line seek of input is the one I'm looking for. Doesn't like. I haven't actually run this yet. does not like that either. Winery, because I haven't done this. Whole chain of things I haven't defined properly. Define your inputs, people. It does not like that. I just need something that does this regularly now. Just make sure I am reading it correctly. Looks good. Nothing's nil. Something doesn't look right there. Do you see that? Something's definitely wrong there. Oh, wow. Yeah, that's really screwed up. Hold on. Stir data. There we go. Let's try this again. Much better. 21188-31669, -2, -3. The parsing seems to be going fine. Great, we're fine. We're fine, we're fine. Okay. Okay, so what I'm going to do is I'm going to look for the point at which the bounding box is the smallest. Let's start there, because I want to see kind of the origin around that, I think. Yeah, let's see what happens there. So, we know how to update a point, or take a point in time. Let's go ahead. I don't know how we're going to do this. So first of all, let's define what the bounding box of a series of points is. The bounds of points are the we're going to take those points. We're going to map them by their position. So get all their positions out. We're going to take you know what? Not bounds, but dimensions. We want the width and the height. Threading isn't going to be much use here, so we're going to just let positions be mapping our positions to our points. Whoop. Let's see. Get our positions out. Min X is, I'm just going to do this the dumb way. Apply min to map first positions, etc. And we're just going to basically duplicate that structure a couple times over. Okay. And do we want dimensions? Okay, I'm going to change our mind again. Bounding area. Come on. Can't type tonight. Okay. So the bounding area of our initial set of points did not like. Null pointer exception. Okay. What's it complaining about? One of my things is coming out nil, I think. Oh, wow. Position. It's not position, it's pause. That's why. Okay, we're good. We got this. I'm just being clumsy with my naming. That's a very large area. I'm really hoping I'm not exceeding bounds by doing this, but okay. Okay, so now what we're going to do, let's pull out the fun tools. We're going to go ahead, take our parsed input, take the reductions. So we're going to, again, reductions shows you each incremental step that a reduce takes along the way. It gives you all the intermediate results of applying reduce to some collection. Do we want reductions? We want iterate. Sorry, giving you the wrong definition here. We're gonna iterate mapping tick point. So we're gonna tick all the points over and over and over and over. Tick, 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 tick. And iterate just applies the same function to the result of that function. So it's like a reduction, but without, you're sort of not doing anything. You don't have a data structure you're working with, basically. You're just saying, here's one result, I'm applying the same function to it over and over and over. So if I iterated the increment function, I just get the next number, and the next number, and the next number, and the next number, and the next number. It gives me a sequence of all of those items. So they're similar concepts, just slightly different. There's a sort of a non-existent sequence that you're iterating over, if that makes sense. I'm sure there's a better way to put this, but for now, just trying to get to work. Iterate that on our parsed input. Oh, we already know we're doing that, sorry. Now, this is where it's going to get interesting. What I'm going to propose is that we partition into two groupings of two offset by one. So it's going to give us the first two, then 2 and 3, then 3 and 4, and 4 and 5 as a series of vectors, basically. And we're going to look for a place where drop while probably do this by saying, like, apply greater than map area. But that's not clear. That's just, I don't like how that reads, honestly. For now, this will do. Then we'll take the first out of that. And the first out of that. So that'll give us this one with the smallest bounding area. Oh, we need something to actually move this to a reasonable size. Nope, we are going to need this. Let this be the case in... I see where I'm going with this? Okay. Looks good. Looks good to me. Okay. Let's go. Okay, this is going to be keys min x, min y, max x and max y. B, the bounds of our points. In. And just like that, we have a much cleaner definition here, I think. And to trim a bunch of points to their bounds, we're going to let our keys min x, min y be taken from the bounds of our points. So we're going to take the same bounding box. We're going to use it in a little bit of a different way here. And we're going to map to our points take their position, and we're going to pow. How's that? Let's try trimming our initial bounds to points just to see how that looks. did not like that. Oh, I used, I didn't have to apply map to anything. Give me a sec here. Okay. There's the end. Let's think here. Let's try seeing what happens if I filter to that. There we go. So that looks right. We got one that's now at 0. And we should have one with the Y at 0 now. Oops. Done. Okay. I like that. I like that a lot. Pipe that to trim the bounds. Okay. And as usual with these, I'm going to go ahead and, since we're just trying to print this out anyway, we only want the positions out. That's cute. Okay, so we got something, it looks like. But I'm going to need a better way to print this out, though. Okay, I might need actually reach for Quill for this one for once. Quill... Clojure. Okay, let's try this. I'll need to kill my REPL. That's the weird thing, so you can only add a dependency with Clojure on or with Cider on, but you can't. Okay, well. Okay, let's open it up. we're going to add a new dependency, which is going to be... It's a very weird picture. Oh. Bounding area, I can say. Did not like. Actually, these are probably both longs, huh? Okay. Oops, no. This is just a... Come on. I guess I'm gonna need this later. Okay, so title, stars, part 1. You get to see me just digging through this process here. Set up. Background is just going to be 0, I think. Okay. And then when you draw, let's add width and height here just for go. Don't need all this extra cruft. And we're just going to multiply width and height. Oh, I see. Kill rectangle. Nope, that's not what I wanted. Let's try kill rectangle. No, definitely not like that. Okay. Oops, that doesn't do this. Okay. It's tidy. In min x, min y, max x, max y, adding width and height to the mix, and voila. Okay. That gives us that. Quill stroke. Cheat sheet here. I think the colors can just be vectors at this point. So I think that's reasonable. I'm not sure their cheat sheet's working. Yeah. This XYZ. Okay, good. I think I should do it like this. One. We only want a single point. I think it's do seek. see. What's the difference between do all and do run? Oh, I think I see. So. Map. Pixels. Set pixel. X, Y. Okay, let's try it with set pixel. Let's just see what happens. I don't think I need these two then. Okay, that should do it, I think. We do need to set the size. Keys are going to be width and height, be the bounds of our points, and that's going to just get injected right here. Yeah, so width and height. I think this will work. Okay. Fingers crossed. Does not like that. Width. Right. Okay. Give us the bacon. Did not like. Assistive technology not found. Oh dear. That is pretty massive. I might be screwed going the quill route. Let's quickly find out what's going on here. Oh crap. This is like a local thing. Holy moly, what? Oh boy, okay. Let's try this out. I hope this works as advertised. Don't look. No peeking. No peeking. Oh my goodness, it's just literally this one thing. And that probably means I have to kill my, well... Hey! Okay, let's try something. So notice actually that's something of a good sign. So that gave us definitely the smallest bounding box. But that is useless to us because the smallest one just happens to not be what we want. But I did plan for this. Oh, I have to actually tell it to kill this first, I think. There we go. There we go. We're fine. We're fine. I have to turn off the window it creates before I can continue. I did plan for this. Somewhat. I'm getting some really bad response times. I think Quill isn't behaving well. I think it's keeping some background process running. We'll find out, I guess. Okay. It might be gone now. Oh, I'm still getting some really weird latency. Hold on. I'd probably be better off using one of those, file formats that's just raw pixel outputs, like they use for the ray tracer problems. Error in process filter. No response handler with ID nail found. We'll see if this keeps causing problems. What I'm going to do here... I'm going to replace this to partition 3. Come on. Okay, I'm gonna have to kill the REPL here. It's dying. I think it's still trying to update the picture in the background at a rate of however many things per second. Okay, frames. Okay, worst case. Dead. Gone. Boom. I think what I need to do here is to make sure I'm actually eliminating... Let's see. Frame rate. Set my frame rate lower here. Let's say... Let's look at their example. One frame per second. Done. Now that I think about it, the colors don't seem right. Let's make this a static color outside of that box. Yellow. Okay, that should do that. I think we're safe. Let's grab our solder repel. Interesting, so it didn't like entirely delete the process either. Assessment unlink. There we go. Things you learn the hard way. How to unlink your current REPL session. Okay, that should have worked. What I want is, I'm going to take 3, I'm going to compare the second and the third. So instead of the, no, third, nth, I want to say 2. Did not like, did I not run? Did not like its nth blah 3 or 2. There we go. What is it? Don't want to think. Do I have to call each time explicitly? Same thing. What is odd is I am seeing a black box surrounded by gray. Which makes me think I'm drawing this too small? Okay, let's just see how this behaves. There we go again. It dies. Okay, this is gonna be really annoying. It's my libraries that are failing me now. This is the frustrating bit. Like, I shouldn't have to be slowed down by libraries going sour when I hope they're gonna do the job. Other people are using Quill just fine, so it's something, it's how it interacts with Cider, I think, that is causing problems. I know I've said that before, but... Yeah, it just breaks horribly. Wow. I don't know what's up. Okay, take two. We're gonna have to find another way to draw these points because Quill ain't cutting it today. I'm gonna go back to our Okay. Well, not getting any luck here, so what I'm going to try and do... We're just going to do a little bit of a hack on this. There was a nice example. PPM formats, the thing. Okay. Right, we're doing something odd here. Okay, we're putting them in a set, and the reason we're going to do that is we're going to say let's see. Is width and height from bounds of aligned stars. Stars set be set of aligned stars. Set of positions of aligned stars, rather. How many pixels wide? Width, height, one, there we go. And now for each see, there's a specific order, I think. You have to do Y first, then X, yeah. That's just 110. Okay, and we're gonna just spit out.ppm header true. Let's adjust this slightly. Two and three. So what we're looking for now is a series where it gets closer and farther. So we hit the point where all the points have come together, and now they're going to be moving apart. And we want to see... We don't want just the first of that. We just want the first. We're going to take all five, and we're going to draw all five. Map from the bounds. Stars in suffix. Okay. File name. Okay. It's going to take a bit to calculate. And these are all out of alignment. Okay. Let's make sure we have that out. Oh wow, yeah, I screwed that up. That's supposed to be... There we go. Oops. Bounds didn't work. Bounds of stars. Of stars. Let's make sure we're working only with the ones that we have. There we go. We had a bad binding there. Okay, let's check my home. Okay, but that's good. That's better than we had before. I'm going to ask it to Map indexed. The map up to 2 overline stars. Let's verify. Map indexed. Index comes first. So you know what I'm gonna do? Okay, that's gonna be lazy though. So I wanna do run. Okay, I should have 5 files now. Ah, do you see that? You see that? Which one did it end up being? It ended up being the one. That is, oh, that's odd. Oh, seems to have broken. But it is the one in the middle, indeed. So it's the one with the smallest bounding box. So my intuition was right. XPF X6KI. Am I reading this wrong? XPF XXXKI. Did I miss something in the problem statement? Did they screw it up again? That makes me concerned. Why isn't it accepting it? Is that not supposed to be an I? Are there points landing outside the bounding box somehow? These are all capital letters, so I'm making what I would say is a reasonable assumption. Is it pipe? L? Lowercase l? Okay, guys. That's a pretty rookie error. Don't use symbols that can be confused with each other in a scenario like this, especially when you mix a whole bunch of capitals and then a lowercase. That's not cool. Solvable, but aggravating. I'm gonna save this one though, just so that we can see it for later. It does make it nice though, because I can just stop as soon as the bounding box is small. Start chart 1. There we go. Oh. It's also nice that Linux already has a built-in ppm viewer. Part 2. We're an hour and 16 minutes in. Oof. How many seconds would they have needed to wait for that message to appear? Okay, so what I can do... I know I can do 2-1. First of percent. Second percent. Screwed up the bounds somewhere. Let's bring up the first. Right, we just need to trim the bounds. Let's go home again. Bum, 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 bum. It's good. Okay. Like that. Let's drop our suffix here. Okay, so now we can do a similar thing. I want to double check how iterate works first, because I'm pretty sure we want to drop the first one. And returns the thing itself. So we're going to take parsed input. We're going to drop 1. Actually, we're just going to drop 1. Iterate. Map tick point percent. Right. Whoops. drop one. Actually, we don't need to do that. We can just do partition 2, 1, take while. This is basically the opposite of what we had before. Oops. Keep doing that in insert mode. Let's just remove that. Count. Oops. I think it'll work. So we're just going to go through and tally how many things it took off of it. What? I killed something. It literally, like, my REPL died. That's odd. What did I do differently? Take while should be finite. Something I'm doing is really causing it to blow up badly. Why would it suddenly start blowing up? This is really odd, actually. I've never seen anything quite like that before. Let's check my buffers again. Okay, let me go ahead and kill my existing weapons. Just to make sure that's not causing my issue. Link. I think I might have been reconnecting to an old session or something. Okay, is it gonna do it again? It is! It's like dying on something, and I'm not sure what it is. Did I do a def instead of a deafen somewhere? Why would it suddenly just start failing while processing normal input? I haven't changed anything else. It's got no process. What the heck? Why would this start doing this now? So, I can't tell what in the world's going on here. Utterly bizarre to me. Oops. Wrong project. Insufficient memory. Well, that might do it. It's like, how's this? I think it's the take while somehow is actually using up far more memory than it needs to be. Let's see. Just to make sure we're reducing it down to a point where it doesn't... I want to use the least amount of space possible, basically. So we'll see if this works or not. Unlink. Reopen. I think it's just taking so long to come together that it's overwhelming. I mean, worst case, what we do is we just, instead of iterate, or we iterate, and we also iterate a time counter instead of trying to do this thing. Honestly, that might be the best route here. What happens when we tick a point? We do use associate. So I think given these, okay. So we're going to remap our stars to tick point on all stars. And we're going to remap our time to be does update take multiple pairs? Oops. No. Okay, that works then. Let's redo this. Okay. Stars of the first and stars of the second. Instead of take while, we're going back to drop while. First, T. So we're getting the time now, that first frame. Oof. Okay, here's hoping this works better than it has been. Come on. Map. I keep doing this with map. $10,521. Adapt tactics. Okay, that did it. And in enough time, too. Whew. Sometimes these things get a little trickier than you want. Let's see. Doing okay. As far as personal, probably not so great as usual. Yeah, pretty bad. Alrighty. Lesson learned. I'm probably not going to use Quill from here on out unless I know what I'm doing with it better. I just haven't used it much before. I know other people have been using it for making pretty good visualizations, but this seems more tuned A for animations and B for an output platform that I'm not sure I have set up right now. Like, it seems like it was playing very strangely with Cider. So maybe not for a REPL context. Hard to tell. Anyway, with that, I think we're good. I'm going to go ahead. These are pretty different from each other, so I'll just leave them as their own separate things. Oops. And indent appropriately, and call it good. Alrighty. Yeah, I'm satisfied with this. There's actually not much I would change about it. It's just mostly getting things in the right places. The whole draw something in the middle of this challenge is a little weird, but I'm cool with it. It seems pretty fast too, actually. It doesn't take too long. It's not lightning fast. It's fast enough. And yes, ostensibly, I could combine these two steps together. I don't feel like it. I could bring in the magic wand and have it fork off into two separate computations once I found the item that is the fastest. Again, I don't feel like it. Good enough for me for now. Okay, with that, I think I'll leave it for the day. It's been fun. As always, enjoy Advent of Code and keep learning languages, especially Clojure. If I can stop streaming, that is.